This video will be based on the topic of entropy. The concept of entropy is fundamental as to explaining why a physical or chemical change is possible. This is particularly important in thermodynamics and engineering, as many engineering ideas are based on these changes. An understanding of entropy is needed to form a Gibbs free energy equation. The results from such equation can then be used to predict the feasibility of a reaction, which is vital for engineers when designing a chemical process. Entropy can be defined as a measure of the degree of disorder in a system. Essentially, it is a measure of the number of ways a system can be arranged. This can be spatial arrangement, distribution of the particles, or the distribution of internal energy in an atom, ion, or molecule. To think about it simply, we can consider a solid, liquid, and a gas. Entropy increases as you go from a solid to liquid to gas. This is because the molecules become more spread out and less structured. The standard change in entropy, delta S, during a reaction can be measured using this equation, where delta H is enthalpy change, the heat content that is stored in a chemical system, and T is the temperature in Kelvin. The units of entropy are therefore joules per Kelvin. For a system, entropy change is equal to the total entropy of the products minus the total entropy of the reactants. If delta S is positive, it means more disorder is produced, so a gain in entropy. This can happen in reactions such as melting, boiling, and dissolving. If delta S is negative, this means less disorder is produced, and so a loss in entropy. Condensation and freezing reactions are an example of this.